Yeah, thanks, Ben. So good morning, good afternoon, everyone. Thank you for being here today. My name is Avinash, and today I'll be discussing with you my learnings of SQL Server disk performance, which I've encountered during my work for last couple of years. So before that, let me introduce you myself. So I work as an architect in processor systems. So basically mostly involved in doing database design and development for enterprise application. So have been working on SQL Server, MySQL, Postgres. Also very hands-on on doing T-SQL, PLSQL and Python. So I have expertise in performance optimization and tuning. On reporting front, I have done a couple of projects using Power BI. So I'm located out of Pune in India. So before we start, I would like to share some story with you. Like a couple of years back, we had uh, a, a project which was a modernization journey of a manufacturing organization which was doing B2B business, and they had their CRM platform where they used to send a lot of CSAT mails, right? They were doing this using Excel and some legacy application, which was not helping them to scale. So we did a modernization for them, and it was built on SQL Server using. So basically, it was done using SQL Server on Azure VM. So what had happened is after we did this modernization, and when it went into production, it was performed very well. They were able to add more and more service centers which were able to process this information at a very quick rate, and they were very happy with the system. And since their KRAs were associated with this, most of the people were using end users were using this system to do their day-to-day task. Right now, what happened after few months? They started facing issues with their dashboards and the screens. Now, the issues were like they were not able to pinpoint like when the issue was getting, occurred, or they did not have any. So it was very sporadic issue. No one was able to tell like at which feature or like on which screen it was they were getting issue, right? So they gave this information to the development team, but development team was asking them more concrete ways to reduce this to identify what could be the problem, right? So it happened for a couple of days, and then what happened is since the issue was like only for like 3-4 minutes, it was very difficult for them to see what was happening. So as day passed, it got escalated, and then these issues started happening like every day twice. Then after much of investigation, it was identified that the issue was because of a default file growth. So what had happened is when the server was deployed, the initial database size was kept to something, and then they forget to actually put the default autogrow of the file. It was just left as is. So the default autogrow was something around 32 MB. And what is to happen that after the database is to get filled, there is to be an event of growing the file, which is to hamper all other queries, right? So this was a very simple configuration which was missed, but it had a larger impact. So this was a very simple. It did not require you to have understanding of anything, but it was a very basic thing which was missed very earlier, and that caused a lot of problems later on in the project. So in order to so this that is why what I want to talk about, like what are the disk IO basics that you need to know. Then how do you measure disk performance? How do you identify disk IO bottleneck whenever there is a performance issue? And also I will help you, like Ben mentioned it. So it will also help you with this knowledge. How can you make a right decision to select a disk based on your workload? And then I will just go through some of the best practices that are suggested. Right. So whenever you think of a disk, right? So this is Azure Managed Disk Type screen. If you see here, you get a lot of information. Like there are different types of disks. Then there are different parameters over here, and you have got some numbers. So you go to any disk vendor, you'll have to understand this in order to make a right decision. So when you want to select right decision, you need to understand what is SSD, what is SSD, what is IOPS, right? Similarly, latency, throughput, and premium. So what I want to do is let us start understand these basics first, and then we'll go in more, kind of debugging mode and something like that, right? So at a very basic, so we have two types of disk available in the market, which is HSD and SSD. So HSD is hard disk drives, SSD is solid state. You must be knowing this, but HSD is more of a mechanical, where you have got magnetic disk, which has got sectors and track, where you have a mechanical handle which will go to that location, read that data, and send it. Whereas SSD uses semiconductor, it's more of an electronic device, right? Since it is mechanical, hard disks are slower, SSDs are faster. Then it is very cheaper. SSDs, since it is all semiconductor, it is an expensive. Hard disks have a shorter lifespan because they are more mechanical and they are susceptible to external interference. Let's say it's a magnetic disk, right? So you might have issues if it comes with in contact with some magnetic area, or it can be spoiled because there is some mechanical read-write handle. Now, what we have talked so far is basic how data is being stored on the disk. But in order to communicate this data with other devices, we need to have interfaces, right? Now, this interfaces, there are like this have evolved over the time. So we have parallel advanced technology attachment where data used to be sent, like it used to send multiple bits at a single time. Then this was converted into a serial where each bit is sent in a serial fashion. So this helped in improving the performance. So with PAP, we were able to send around 100 Mbps. With SATA, it moved to more than 150 Mbps. Then there was another technology which was small computer system interface, which was generally used to connect with other devices. So that was used. And currently we have this non-volatile memory express. So basically it uses a high performance NUMA memory access optimized protocol. And all the previous technology uses one queue, but this has multiple queues. And since there are multiple queues, each of the queues can be handled by different cores. So the multi core machines were able to use this non-volatile memory express and get maximum throughput out of that, right? So this is a basic about hard disk. Now let us try to understand different units. So basically the smallest unit. So allocation unit is the smallest unit that is used to manage disk. When we say it's the smallest unit, actually it is the maximum size of data that can be read or written on the disk in a single operation. Now, this is also referred as block or cluster on Windows. So whenever you create a file, there are a number of blocks that are getting associated based on the allocation side. The more the size file grows, you will be adding more blocks or cluster to the file. Now you can check what is the cluster size of your disk by using this command fsutil fsinfo ntfs and the drive for which you want to look. It will give you the values under bytes per cluster. So in this case, it is 4 KB. The allocation unit size is 4 KB. Let's try to understand how. Let's say I have a 5 KB of data that I need to write to a disk, and my allocation unit is 2 KB. So the operation it will perform 3 operations, and it will create a block size of 2 KB. Since allocation unit is 2 KB, so it will create 3 blocks of 2 KB, and my data will be stored in this 3 operations. Right. So this is allocation unit. Next, we move on to IO operations. So what are IO operations? IO operations are nothing but the number of operations that a hard disk can perform in a per second. So basically it's counting. This is the number of operation. Now it depends upon the allocation unit also. Let's say you are giving some file to be saved on the disk. Now based on the file size and the allocation unit size, the OS will split that request into multiple requests as per the allocation unit, right? So let's see. So we had already seen this example where we had 5 KB data with 2 KB to be written on a disk. Now let's say we have same 5 KB data, but we are using a 3 KB of allocation unit. So in order to do this operation, it will take 2 operations and it will create 2 blocks, right? So as you here you can see that as you increase the allocation unit, the operations are reduced. Similarly, if you have more operations, you'll be able to write more data with the same allocation unit, right? So now let's move to another topic. This is throughput. Throughput is nothing but the amount of data that can be read or written per second. So basically, it's a factor of your IOPS and IO size. Now, as we discussed, the allocation unit is the maximum size of data that you can write in a single operation. There is also limitation on how much max input operation can be performed on the disk. So this is called as max IOPS, right? Now, to measure the throughput of the disk, we use a formula where max disk throughput is nothing but allocation unit and the max IOPS. That is how the maximum number of input operation that can be performed in a particular in a given second on that disk, right? So here I'm putting an example where I have a max of 1,000 and I'm using two allocation units, 64 KB and 4 KB. So in case of 64 KB, if I utilize my 100 IOPS, I will be able to write 62.5 MB per second on the disk. But if my allocation size is 4 KB, with same number of operations, I will be able to write 3.9 MB per second. So this is very important to understand how IOPS allocation unit will affect your throughput. Right? The other most important aspect is the latency. Latency is nothing but the time period between your request and the time you get the data. So basically, it's a it's whenever you ask for data and you get data, the time frame between that is a latency. Now this latency can be at different level. It is we had seen, like, we had SSD and then we had interfaces, right? So those interfaces were introduced to improve the latency, right? Now you can also have latency between, say, your like your database is giving you results to the server at a quick rate, but you have a network latency, right? So that is also kind of adding to a latency, right? So we have covered the basics. I just want to understand if there are any questions with this basic principles or factors that we have understood. Is it clear?
It's clear to me. There's no messages in the chat. I think you can continue.
Yeah. Okay, so now we have understood what are the factors that are to be considered while we are looking at the disk performance. Let us see how do we measure those. Right. So measuring is very important. Unless you measure, you won't be able to take any actions. Right. So if you really see, there are counters available. There are different counters that are available with all disk types that are available on prem, cloud, and maybe AWS. So like we just see. So these metrics are nothing but it will count the number of operations that it is performing. It says that disk reads per second, right? Similarly, disk writes per second, right? And disk transfer is nothing but total number of disk writes and writes. Disk reads and writes. Throughput is nothing but the amount of data that is written. In this, you can see there are people. The people after every operation, the count of people is increasing. So that is throughput, where you say the amount of data after every second. That is the counters, which says disk bytes per second. So how many disk bytes were read, written per second? This is throughput. And then we have latency. Latency, as I discussed, it is nothing but the time taken between the request and actual data that has been received, right? So these are three category of counters. Those are very important for you to measure. When you're talking about measuring, there are two ways to measure this. If it's in Windows, you use perf monitor. If it's in Linux, you use IOStat, right? Like there are other counters also that you can measure with this, like queue depth. So queue depth specifies how many number of outstanding IO requests are waiting, because there are some IO requests which are being in action right now, and there are some since you have large data to write, some of the data has to be kept in queue, which will be processed once the existing is finished, right? So these are some of the storage metrics that you get using these tools. We'll go in detail of each of them. Perfmon, right? This is the tool that is available with Windows. You just go run, type Perfmon. You'll be able to see this screen. Select performance monitor. Then you click on this plus button. It will give you add counters. Okay. Now here it is not only that you will get disk related counters. You can get CPU related counters. You can get memory related counters. You can get network related counters. So this tool will provide you a lot of information of other things also, right? So currently we are mostly focused on physical disk related. That is the reason we are taking those three important counters, and we just say okay, and it will start showing you what is the current value for those counters, right? So this is one way of getting counters using Perfmon. There is another way using PowerShell. So you can use PowerShell where you mention like what are the counters that I need to fetch. So here what I'm doing is a physical disk, and I need to get average disk per read. So you can also have a parameter where say I need to get average disk from a C drive, D drive. That is also possible. And we are saying that get counters. This is the command line that you're using. Get counters. We are specifying what counters do I need, and then I need to get this counters for every 2 milliseconds. Sorry, 2 seconds, and it should have for last 20 samples. Like every time it is generated, it will show me what was for last 20. So it is kind of just buffering those values. Now, if you move to Linux, on Linux, there is this iostat command, which will help you provide statistics around CPU and devices. So the first part is CPU, the device part is all about this, where you have total transactions per second, then what is the kilobytes of read per second, or kilobytes of write per second, likewise. So these are again counters which we had seen earlier. This is on the Linux machine. Similarly, on Azure VM, right? So if you're using Azure VM, these metrics are also available through Azure portal, and these are updated every minute. So basically, there are again IOPS related data disk operations throughput. There is additional few counters which are available with VM, is like storage IO utilization. Since Azure is kind of a provision resources where we know that we have provisioned something with some value. So it will always tell you what is the percentage of that utilized. So if at any point, if you see that these counters are hitting 100% utilization, you need to figure there is a cap, and you need to look for issues. You might face issues in the disk performance may decrease. You also have a data disk queue depth available with Azure VM. Right. So now what we have done is we have identified what are the counters. We have identified how to measure those counters both on Linux, VM, and Azure. Similarly, we also have on AWS. So you can even find out there that these counters are available. So now we know what to measure, right? Now let's say that you have an issue, right? What do you do about if there is a performance issue that has been reported? So we need to know like how we can identify if there is actually a disk related issue, right? So we'll move to next thing where we say I need to identify my SQL disk bottleneck, right? So here, what I'm going to do is I'm going to take a very simple approach where I will just explain you if you can figure out, okay, is it related to IO? All these methods are like not a concrete proof that it is an IO related issue, but it indicates that there will be an IO related issue and you have to do a further investigation, right? And I'm considering this like you don't need to have very technical related knowledge, in order to identify this. So we'll start with first. First is latency IO stalls. Now, IO stall, what SQL Server does it, whenever it is waiting for some IO, it will store this as an IO stall in its database, right? And this data is available using a dynamic management view called DM IO virtual file stack. Right? This is a query that you can fire in your SQL Server. So what we have to do is we have to find out the average total latency. That is nothing but the IO stalls for read, IO stalls for write, and the number of reads and writes that are performed. And this is a rough reference to ULT. If your average total latency is less than 22 milliseconds, it's good. If it's between 2 to 5, it's very good. So you have this reference. Based on this, you can get an initial understanding whether is there any performance issue which is connected to your disk IO. Okay, let's move to second part. The second part is so whenever a SQL Server is waiting for an operation on an IO operation for more than 50 seconds, it will log an error message in its error log. Right. So basically, SQL Server is doing this for every task. If it's waiting for more than 50 seconds, it will log an error into error log with details like what was the database name, which file it can occur, right? Now, in order to read this error log, there are again two ways. One is using PowerShell. Now, to read PowerShell, we need to identify where the error log is present, and you need to be present on that VM because you need to access that error log. So in that case, first you need to figure out where my error log file is. You can use a server property command select query, which will give you the error log location. Then you use a get child item commandlet where you mention the path of the file, and then you say what is the search string that you want. So the occurrence of IO request taking longer than 50 seconds is the message that is being written by SQL Server in this error log. You just go and find if it's present there. If it's present, that means there is some issue with your disk not able to perform IO operations. Right? If you do not have access to that VM, or you are not able to access the file error log, there is another way which SQL Server provides is using this XP read error log command. This syntax is very simple. You just have to call this SP using log number, log type, and search time. So log number here refers to the error log, which is the current error log. We identify it using 0. And if since error logs are generated, like there are files that are generated, in a cyclic manner. So you might have logs which are in the past. So you can also check the past log, the archival log, using error log 1, 2, 3, like that. And the log type parameter is nothing but there are two types of logs that are generated. One is the server log and other is agent log. We need to search for the server log. And again, the search item is same, taking longer than 50 seconds. So if this SP returns you, it will return you the error log, how many times this error has been logged in your error log. And based on that, you can identify that your IO is under pressure and you need to look into that. Right. So
one thing, there is a question in the chat. What PowerShell and which version do you use to perform the checking?
Can you repeat that again, please?
What PowerShell and which version do you use to perform the checking?
So I guess this is available by default, like PowerShell 7 and above. So basically what we are doing is we are actually, this is nothing with SQL. This is just you're doing a file search kind of thing.
Yeah, I actually think that would work in any version of PowerShell.
Yeah, any version.
The two commands there, get child item and select string, that's native general PowerShell. There's nothing special there. You could use probably PowerShell 3 or something as well.
Yes. The only thing is you need to be on that VM where the it won't be able to do a remote file search, and you need to know the file location, which you can get using the above command. Hope that's. Do you have any other questions?
There are currently no other questions in the chat.
Yeah, so let me proceed ahead. So the next important way of finding any IO related issue is using wait types. Now this is the most important, or like this is the most widely used tool used by any DBA or anyone who is doing performance optimization. This is the what would say this is the Swiss Army knife. You can do a lot of things with this, right? So what happens is while execution, whenever SQL Server is performing some operation, and if it has to wait for something, right? So it will log that information, like it waited for this and it waited for so long, right? So that is what wait types are, right? So wait types are all the wait types that SQL Server encountered while doing an operation, right? Now, this is also applicable for CPU, RAM, and other stuff, right? So in order to identify IO problems, we use this. These are the 6 important IO types that needs to be looked. Now, again, they can indicate IO problems, but you will need to do more investigation in order to reach to a conclusion. Okay, the issue was because of IO related, right? So again, there are 2 DMVs associated with this. One is OS wait stat. Now this DMV will give you information of all the wait stat. This is a cumulative across server. And exec request will give you information about a currently executing query, right? So both have different ways to look at. We'll look that further. Okay, so let us try to understand this IO wait types in details, right? So basically page IO latch, right? So what happens is SQL Server, whenever we are doing any operation with the SQL Server does not directly communicate with this. It has got something called buffers, and all the write read information happens to buffer. And since we have to maintain ACID property, we cannot do, while writing, we need to take logs, right? So that is where this page latch IO exclusive log is taken when you have to write to a buffer, right? When you have to write from buffer to a disk. Similarly, when you're reading, you have to acquire a shared log. That is when this page IO latch asset is used. Now, in order to read, it will have to first get this latch or this log, and then it will have to perform the read operation. But because of some reason, you're not able to acquire this log, so it is waiting for this log. So that is the wait type that has been captured over here. right? Now with this, as I mentioned earlier, like this won't indicate, this won't give you a right idea that there is a IO, like there are other root causes also for this IO type. Like let's say your buffer size is very small, right? So in that case, there will be a frequent read writes that are happening. You have insufficient memory, then you have to always harden the things that have written to your buffer. You will have to, because your memory is very small. It needs to accommodate with all the requests, right? So it will continuously do a kind of buffer hardening, or the saves are always hardened, right? So it will have to do a frequent hardening. So in that case also, there will be cases where this IO types will be rated higher, right? After this, there is second wait type, which is IO completion. Now this does not happen with the data index pages. This is basically whenever you do a bulk kind of operation or TempDB, right, where you have to do do a bulk read write. In that case, this operation is, this wait type is been measured and logged. Right. There is another thing is write log. When the transaction is waiting to flush to complete, like basically what happens is transaction log, whatever operations are performed, it is first committed to transaction, and then this transaction log is flushed to the hard. So the changes are hardened in the hard disk, right? So that is where this wait type is encountered. Now the other root cause also might be that let's see that in a particular SP you are doing row by row operation, and we have set a transaction. So what will happen is, like if you are updating 10 records, if you have done this row by row operation, so you'll be doing 10 commits, and it will create 10 transactions. Instead, if you could have done a set-based operation, there will be one transaction and you could have committed all the data in that. Okay, so in that case, if you're using lot many transaction, you tend to get this write log wait type, right? So you'll have to identify what is the real root cause of this. And the last one, this two, both sync IO completion backup occurs during backup and restore, right? So basically, it might happen that you have a SQL server running with a high load, and at some point of time, there are backups which you have set up for doing disaster recovery. This will also impact, because your data which you need to pull in order to backup, it needs to read from the disk, right? So this wait types will be logged at that scenario. Right? So now let us try to understand how can you access this DM this, right? So basically, so when I initially mentioned that there are two DMs, OS wait stat. This is a cumulative kind of thing. So basically, this will collect all information. So what it does is it says, okay, for this particular wait, it waited for 2 seconds. So it will always collect this, and this is a cumulative count which you get since the server started. So the data is not persisted. If you do a server restart, all this information is lost, and it again started, and SQL Server will start recording this again. So basically, if you want to look at a very broader perspective in your database, like what are the other wait types, or what are the wait types which are more prominent. So this can be again used for identifying other issues with regard to memory and CPU, right? So these are the 6 which you have to look for, and if you find that there are higher wait times for any of this, especially page log, page latch, write log, IO completion, then you can further investigate on this. Right? Similarly, there is another DM exec request. Now this is used to find out what are the current wait types that are occurring when your query is being executed, right? This is for the current session that it is taking place. Again, this could be this will suggest IO performance issue, and it will need further investigation, right? Because we saw, right, that there could be other things in parallel that might be happening when you are doing for a current request that will affect this thing. So if you identify that there is a higher wait time for this, then you can further investigate on other issues. Right. So what we have identified is we have identified counters. How do we measure, and what to do when we encounter an issue, right? We have identified what are the ways to identify this. Now, before moving on to this next, I would like to again tell you one small incident which happened with us, right? So basically, we were doing this project for a social media campaign, right? And we had again this SQL server which was hosted on Azure VM, and what was happening is we were getting a lot of social media interaction which were captured from Twitter, Facebook, and that was fetched in our database. And we were doing some kind of kind of operations, doing rule-based operations and creating leaderboard. And we were showing like how far you are from the current leader and all those stuff, right? So what was happening is there were a lot of calculation sorting and that was required while doing this reporting. So after we were facing some performance issue, and when we identified the root cause, so basically when we look at the configuration, what the IT team had done, they had provided separate disk for data, TempDB and log, but the TempDB disk which they were using was not of great speed. So what we suggested to them is to instead, since it's a Azure VM, we had a temporary SSD available, which is available with all Azure VM. So we suggested them to move this TempDB to that temporary disk, and in that way, they got better performance because it was an SSD. It was far better than what they were using. Also, it comes with a free of cost. Right, so they did not have to pay much. The only thing they had to do, we'll look into like when we look at the best practices, like when there is a restart, we need to just manage how this can be taken care of. Okay, now let us move to this, like how do you choose a right disk, right? So basically, there are four things that you need to understand while you're trying to get the right storage for your application. Storage metrics we have already seen. We'll understand what IO workload pattern are, then what is storage setup, and what are storage availability, right? So we have seen storage metrics. We'll move to IO workload pattern. Now, so basically, SQL server users following workload patterns. So these are the patterns in which files are written or accessed. So data files typically, since data is requested in random fashion, it does a random read write, and the requests are made in 8 KB and 5 KB in size. For log files, they are typically sequential because logs are already sequential, and it writes in 512 to 660 KB. TempDB is again kind of a data file. It is heavily used for an intermediate results, right? So that is the reason we should have our TempDB always on a fast drive, because it is going to store intermediate results for all the query executions, right? So it has to be a very fast disk, fastest disk on all the disks. And backups, backups are always a sequential, and it reads in 2 MB in size. Now there is another aspect when we talk about application workload, like what is the nature of your application, whether it is read intensive, write intensive, or computational, right? So read intensive is something like when you're doing a lot of reporting, like data has already been stored and you're just doing for analytics purpose, then you'll be doing a lot of reads. So in that case, your load is more of a read intensive. Write intensive, when you do like when you're collecting data, you're storing data, right? So that is where you will have to understand that the disk will need a good write performance, right? In read intensive, you can use in some cloud you can use read only servers, right? So basically you can have those. In computational is where you do a lot of processing. Now in this case, you need to see that your CPU, your RAM, and TempDB is at a higher side so that it could satisfy. So understanding workload pattern of your application is very important. Based on that, you can take a decision what kind of disk I will need, whether disk will be my priority or RAM and CPU will be my priority, like that. And within that, you can say whether it is read intensive, write intensive. Based on that also, you can decide. Right. Now let us understand the storage setup. Right. So basically, whenever SQL Server stores stores data in files, it primarily has three types of file. One is primary, second is secondary, and third is transaction log. Right. The primary is has all the startup information and it will have a pointer to other files. Secondary is NDF, and you can have multiple secondary files in your file group, right? So now all these files are grouped together logically in something called as file groups, right? So again, now file groups give you an ability to logically combine multiple files, right? So primary, so you might have, let's say you want to have 3-4 data disks, 3-4 data files. You can keep those data files on different disks in order to utilize disk efficiently, right? So you can have multiple data files, all those files will be on different disks, and you can group them into a single logical file group, which you can associate with your database, right? So basically, user-defined file group contains secondary files, and those are all files which your database will use to store data. And since you're using multiple disks, if you're using multiple disks, you will be able to read a lot faster because you'll be having different read-write read kind of mechanism to read from different, like it could do a parallel reading from different disks, right? There are other file groups which are used to manage memory optimized data and file stream. This is like more an advanced kind of thing with the file stream and memory optimized table. So in general, this is how your storage setup looks like for SQL Server. We need to understand this, and it is recommended that you have each file on different disks. And also make sure that when you put your temporary file, it should be on the fastest possible disk. Again, now it depends. If you do not have a very computationally intensive workload, then it is not required. But if you have a lot of computation where you do a lot of sorting and other, there's a lot of speed up happenings while you do query, then TempDB comes into picture. Right. Now, okay, now we are talking about water availability, right? So basically hardware vendors will provide you with the information that they have. So basically we have understood what is IOPS, we have understood what is throughput, right? And similarly, if you go to AWS, you also have this same number over there, that what is max IOPS, what is max throughput, right? And most of these cloud providers or hardware vendors also have a specific or advanced feature which are specific, which they have come up with the latest technology, which will give an additional benefits, right? We'll look into that. So like on every cloud provider, you have this information. You know what, if you select, let's say for Azure, if you select P1, what is the max IOPS I'm going to get? And now this throughput will go to understand what is max throughput with bursting. So bursting is, and as I said, it's an advanced technology that is provided by Azure. Similarly, there is something which AWS provides, and GCP also has some things additional to whatever we have seen as a basic, right? So like when choosing option, you have this advanced feature. Like we'll go like what is the memory or local SC used for better performance, right? So caching. So caching is nothing but you have a disk and you have your actual requesting of process. In between, there is a memory which is SSD and which is used for caching. So your data will be cached. So this normally be our SQL Server has buffer, but this itself will provide you a caching mechanism where your data will be stored and it will be accessed fast. Then stripping. So basically, as I mentioned, like for a single database in a file group, you can have multiple files which will help you, get the maximum output with all the doing it parallelly. Similarly, stripping is nothing but you multiple disks are combined to aggregate the performance. So basically, if you say that one disk gives you 10,000 IOPS and second disk gives you 10,000 IOPS, then if you do this in parallel, you will be able to get a capacity of 20 IOPS is what you can get, right? Now, Azure comes with something called as bursting. So bursting is nothing but since it's on Azure, it's all like a provision, right? So what they do, they say that if you want a better performance for a certain period of time, you can boost that for a particular disk. So basically, for a limited period of time, you can increase your throughput or your capacity for a particular disk, right? And there are optimized disks. So there are like disks which are optimized for certain workload. So these are the advanced features that are available with most of the cloud providers or vendors. You need to look at this, identify what your workload is, and based on that, you can arrive on what is to be selected, or what will be the best that you should be using for your application workload. So we have covered how to choose. Now let us. So do you have any questions before I move to best practices?
No, there's nothing in the chat.
Okay, so let us. So we have identified counters. We have seen how to measure them. We have seen how to identify their issue. We have seen what factors to consider while deciding which disk to be used. Now let's move to some best practices which are very common that you can use, or you should apply it by default. So basically, like for data files, as I have mentioned earlier, so that you need to keep data and log temp files on separate drives. For temp file, if it's a very compute intensive and you see a lot of spillover happening, then you can keep that on the fastest drive. Okay, so again, log files, see, because what is happening is every changes to the database are added to log files, and this log file needs to be hardened to the drive, right? So this, in that case, there needs to be a faster response. So in that case, you need to have your log files on the fastest writing drives, because it is nobody is going to read more from the log. It is mostly for hardening your changes to the actual file, right? Now, the third one is set database location. Now, what happens is many a time, so let's say you have this different locations for different, you have a different disk available on your server. But if you do not set the default database location, what will happen next time you create a new database? It will use the default location, which will be your the installation drive, and it will create most of the data files and log files there, right? So even if you're having different disks on the server, if you do not set this default database location, all the files will be created on the C drive, that is the OS, or whatever is the default database location that you have set, right? Then the fourth one is the auto growth, right? So initially when I started, I gave you an example how this auto growth setting created problems, right? And how difficult it was to identify, because it was very sporadic kind of thing. So every time, make sure that you have a proper auto growth settings. Make sure you have this, as a checklist from a periodic time of point, that someone will go and see, okay, what is the current file size and how it will grow. You need to provision that beforehand. This enable insert file initialization. So now what happens is, whenever you do a auto growth of a file, so the initial data which is there on the disk gets erased, right? So if you do an enable instant file initialization, it won't delete that data. It will just acquire that space, and SQL Server will start using that without doing any delete or resetting data on that portion of disk which is acquired as a file growth. Right. So this will help you with the problem that we had with the auto growth, right? So it won't be, the auto growth event won't be longer. It will be a shorter one. So it will just acquire the space. It won't do anything with that. Right. Now let's see attempt. Throughout discussion, we have been discussing more of a TempDB is very important, very critical. So there are some best practices, right? So placing TempDB, placement of TempDB is very critical, right? Because it will affect all the query execution will use TempDB for the intermediate results, right? So it is always suggested that use a dedicated disk and use all space available. So again, if you use a dedicated disk and if you do not set a proper auto growth, right? See, since you're using this dedicated disk, say it's 100 GB, and if you're using 10 GB of TempDB, right? The rest of the space is not being utilized by anyone, right? So you should ideally utilize whatever is available, right? And if you're using less, then you need to see that your auto grow is being managed properly. Now there are good best practices which suggest that your TempDB, you can have multiple files, right? Multiple files will help you in better performance. Now, the number of these TempDB files is like, a little bit, some say it should be 8, some say it should be like the number of CPUs. But ideally, what is suggested as a best practice is you start off with the 8 data files, no matter how much CPU you have. And if you see problems, then you can increase from 8 to 16 in multiple of 8s, right? We discussed on Azure VM, you can place the TempDB on the local FMLSD. This is a free of cost, and it is SSD, it is local. And you get you can use use the high OPS and low latency available with this SSD. Since it is temporary storage that is provided with the VM with no extra cost, there is one issue that whenever the VM is moved or whenever the VM is resized or restarted, this storage is destroyed and you get a new disk. So in that, when such thing happens, we need to create a batch file or a job, which on every startup it will create this folder structure. See, we will be having TempDB location in the database configuration, that won't change, but the folder structure or the file will be there, right? So you need to create that folder structure. In order to do that, for every startup, we need to put in some script which will be able to create that folder structure, so that when SQL Server starts up, it will find that location and create a TempDB file for us. Right? So this is one important thing that you will have to take care of. So do you have any questions?